graphing the sine function. So we like to use trig functions when it comes to things that go through cycles. So in nature, if we think of the seasons, the moon, the tide, those types of things, they're in a predictable cycle that we can graph, or like your guys' sleep pattern, or like the average person's sleep pattern, heartbeats, because they should be in a, like I get it, like an EKG gives you all of your, I can't even think what they're called now. All I can think of is SP and IP, and that's not it. That's your guys' attendance. But our sine, or any sine and cosine functions, they have to do with cycles, and they're going to continue to repeat. So we're actually going to make graphs that look like this today. Sound good? So for us today, we want to look at, to graph y equals sine of x. Okay. And we used to have like sine theta, and we just like x's and y's, right? So instead of just putting in the theta, we just leave it as, we put it as an x, and then our y is y type thing. Sound good? So our generic formula for graphing sine functions, we say is y equals a times sine of bx. And if we look at ours, what's our a value for our red one that we're going to graph? What number is in front of sine? A 1, right? And what's the number in front of x? 1, right? This is, we're going to graph the most simplest one when we have like sine equal sine of x, right? But this is where we can put in different numbers, and you guys will put in some different numbers, and we'll put in some different numbers. And then a and b tell us how to actually graph our sine function. The first thing we always look for is called the amplitude. So the amplitude is kind of like the height. The amplitude has to do with like how far above the x-axis you're going to go and how far below you're going to go the x-axis. And we get our amplitude, that is the absolute value of a. So I would put in there how high and how low. You can make a song out of it if you want. Well, that's yeah. Yeah. The second thing we look for is called the period. So our period is going to have to do with where it like repeats, how far it takes in order for our cycles to repeat. So we know going all the way around the circle is how far? 360. Or also like 2 pi, right?
Yeah.
So if we do 2 pi divided by our b, that's going to tell us how far it's going to take in order for our function to start repeating again. And then the third thing we do when we want to graph is we need some points on our graph. So we know how high, how low, we know how quote unquote how long or how far it's going to take. Oh, we can do that. Yeah. This is where the cycle repeats. Sorry. Throw that down there so you know what that means. So you know what a period means, right? And we know how long it takes in order for our cycle to repeat. So now we just need to plot some points just to kind of figure out what's going on. So there's always 5 important points. Five of them. So we can think of these as intersections. Can't write on this side. Or turning points. I can keep going. I forget how many words we can have. Okay. Intersections are where they're crossing something, so we're really looking for where they're going to cross the x-axis. Turning points. What's a turning point? If I got a graph going something like this, what would you think a turning point would be? Yeah, right? So if you're going up and then you're going to turn and go down, right? Where you're down and you're going to turn to come up. Yep. So the first one you're going to always find is when x equals 0. So that's going to be your y-intercept, right? If x is going to be 0. And then the other 4, you're going to take your period from up here, and whatever you get from that, you're going to divide it by 4. And then that's going to give you 4, well, it's going to give you a value, right? And so let's say that value was 2. So you're going to check it at when x equals 2, and then x equals 4, x equals 6, x equals 8. Does that make sense? It's a little bit easier once we do a problem to see where those 4 points come from. Sound good? All right. So some of you are asking, well, haven't we already graphed these? Like we made a circle and, you know, isn't that a graph? Yeah. So, oh, now we don't, oh, I have a circle tool. Make my circle white. There we go. So, we were looking at these little guys, and we threw some x and y axes in here. And then we kind of like came up with some angle, and we're like, oh, you know, let's say about like this angle, and we said like this was our little theta. And there was a point where our little angle crossed over that circle, right? And we knew that that was our x and our y. And when we started putting trig functions in there, we said that our x was the same thing as our, starts with the C, our cosine, right? And our y was our sine, okay? So the reason why we're going to come up with putting a graph in our nice little coordinate plane is we technically got 3 things kind of going on here, right? As our theta or our angle changes, our sine and our cosine changes. So we technically got 3 things that are changing, right? We got theta, we got sine, and we got cosine. And I think it's kind of hard to graph 3 things in a 2-dimensional space, right? So when it comes to graphing sine and cosine, you're only looking at one of those values at a time. So granted, our theta, which is going to change, right? Our y value is going to change. And then we're only going to look at the sine value today. And then tomorrow, we're going to look at the cosine value. So I want to take all that good little information. And I want to be able to graph it. This is where I missed my little pointer. I don't have a pointer on here, do I? No. Alright. So if I'm talking about sine, I'm talking about my y values, right? And I'm going to start by right here. What's my y value when I go to start this guy? What's y right there? 0, right? So I know that I'm going to start at 0 when it comes to sines. So now we just need to think about our y values for a moment, right? And what's happening with our y values? So my y value is starting at 0. What's happening with my y value as I go up to 90 degrees? Yeah, from here to here, my y value is going up, right? But then what happens when I get here and I come down to get to 180 degrees? What happens to my y value?
Decrease.
It what?
Goes down.
It goes down. Then what's my y value going to do from here to here?
Going down.
It's going to go down.
Up.
And then it's going to come back up. Right? So in a nutshell, right? What did we say our y value did? It went up, and then it came down, and then it came down some more, and then what did it do?
Came up.
It came back up. And we went around the circle once. So this technically would keep continuing, because can you keep going around the circle? Yeah. So, but this here is one cycle. Because you cycled around once. And then you can kind of keep going with that same graph. Keep going. So remember when we talked about our 5 points? Right? So this would be your first point, right? When x was 0. Here's your second point where you're turning. Your third point you're going to find is where you cross the intersection, or cross the x-axis. This is your turning point again, and then where you cross. So those are those 5 points that we're going to find. And then once we find those 5 points, then beautiful graph. All right, you ready? So we wanted to graph where y equals sine of x. Okay. So the first thing we got to find was our amplitude, which was our absolute value of a. And for us, what is it? Our a equals 1 and our b equals 1. Everybody good with that? Yeah. So we get the absolute value of 1. And what's the absolute value of 1? 1. Once you take the absolute value, can you ever have a negative number? No, because the definition of absolute value is? Definition of absolute value? Distance from 0. Yep. Yeah. So we know that our amplitude is going to be 1. So we'll get to doing the graph. So what that's telling us is from our x-axis, we're going to go up a value of 1, and we're going to go down a value of 1, right? Because distance from 0, so our axes are 0, so up 1 and down 1, right?
Yep.
The second thing we had to find out was our period. So we need to know how far this is going to go to repeat. So to figure out our period, 2 pi all the way around the circle divided by our b, which is 1. So it's going to repeat every 2 pi. So on our y-axis, or our x-axis, we're going to be counting by pi's. All right. So our third thing was figuring out those important points. Oh, I bet you I could have graphed it as we went. So the first one was when x equals 0. So, and if you think about it, if you wanted to plug that in, you are finding sine, whoops, not theta, when sine is 0, right? And if you look on your unit circle, our sine of 0 is going to give us a value of 0, right? And then the other one was where we, the intersections and the points. So the period, what was our period? 2 pi, right? And we want to divide that by 4. Okay. So that's going to reduce, what's that going to reduce to? Pi over 2. Right? So every pi over 2, right? So there's our first point. Where's our next point going to be? would be pi over 2 plus pi over 2, which is pi over 2 plus pi over 2. What was it? Yep, 2 pi over 2, which is pi, right? So there's our next point. So to get to our third point, what's it going to be? Pi over 2 plus pi over 2 plus pi over 2. What's that going to give us? 3 pi over 2, good job. And then our last one is going to be pi over 2 plus pi over 2 plus pi over 2 plus pi over 2, which is going to give us
4 pi over 2.
Yep, 4 pi over 2, and 4 pi over 2 is going to be
2 pi.
2 pi. You guys good on those points?
Yep.
Alright. So let's try and graph this little guy. And I'm just going to do probably got room for like that first little cycle. Perfectly drawn little axes. Alright. My amplitude is 1, so that's my distance from 0 is 1. So I'm going to go up 1. Then I'm going to go down 1. And that's technically negative 1, right? So my period is how far it's going to take in order to repeat. So somewhere down my x-axis, I'm going to mark that this is 2 pi. And I'm going to take my 2 pi and I'm going to divide it into 4 equal spaces, right? So a lot of times I go ahead and mark them like half of that, right? I think halves are easy to kind of measure out as opposed to fourths. And then you're going to take half. And you're going to take half. And then personal preference on if you just want to go through and just write all of those in. Or sometimes I just go, I'm at 2 pi. What's half of 2 pi? Pi. Right. What's half of pi? Pi over 2. And this one's going to be my 1.5 or my 3 pi over 2. Alright. So now the fun part. So we know that when we put in x of 0, when we look for the sine value, when our x is 0, our sine is going to be 0. So there's your first point. Okay. Always look at your function. If it's positive or negative, it's going to tell you the direction that you're going to go, right? So if you think of if we had a positive line or a positive quadratic, it's going to go up, right? It's going to start by going up. So the same thing happens with sine and cosines, right? If that's positive, you're going to start going up. If it's negative, you're going to start by going down, right? So ours is positive. So to figure out our value for pi over 2, we have to go up. And we're going to go up to our amplitude, which is 1. We're going to go up to 1, okay? And that was our turning point, so then we're going to start coming down. What do you think is going to happen at pi? We're going to go through. right? And then what are we going to do from there? We're going to keep going down until we get to -1. And then we're going to come back up. And yours guys just have to look better than mine, right? If they asked you to do one cycle, you would just do that. If they asked you to graph it, we know that these guys go on and on and on forever. So then just kind of give some arrows at the end. Alright. Or if you wanted to, you could even make it bigger. Right? It's going to keep repeating. Right. Try another one, fancy one. So, and when it comes to our sine, like they'll all look relatively the same. It's the parts that are going to change for you guys are going to be like the amplitudes and then the interval in which they repeat, right? We knew that on ours, because this one is telling us that 1 is going to be your amplitude. This is like your radius of your circle. If you think of our unit circle, how high did we go up when it came to our y values? 1, right? Because that was our radius of the circle. So ours went through 2 pi. This is what's going to change, are these 4 values, and then whatever your amplitude is. But because you're going to be splitting it into 4s, most of your graphs are all going to look alike. Right? So, what if we wanted to graph? Let's get fancy now. You want to go for a negative? How about a -3 sine of 2x? So what's our A equal on this one? Just A, not amplitude, but just A. -3. And what's our B going to equal? 2. Right. So first thing that we always want to find is the amplitude, the absolute value of A. So the absolute value of -3 is 3. So the distance from our x-axis is going to be 3. Okay. What's the second thing we want to find? Our period. How do we find the period? Yep, 2 pi over b. So that's going to be what? 2 pi over 2, which is going to equal to pi. So on this one, our whole cycle is going to repeat from 0 to pi. Right? We want to find those 5 important points. So the first one is when x equals 0. What's our sine value going to be when x equals 0? 0. It's going to be 0. Yep. And then the other points we need to find out by taking our period and doing what? Dividing it by 4. So there's point number 1. Or I guess technically number 2. Right? How are we going to get the next one? Pi over 4 plus pi over 4. Which is going to give us 2 pi over 4, which is going to give us pi over 2. Pi over 4 plus pi over 4 plus pi over 4 is 3 pi over 4. Maybe I don't have to write it all out, right? 4 pi's over 4 is going to give us pi, right? Which is always going to be that one that you end with, right? You know, that's going to be pi. What's my amplitude gonna be? 1, 2, 3. 1, 2, 3. You wanna be all fancy and fill everything in? Okay. My cycle's gonna end at pi. I gotta split this guy up, so I'm gonna go ahead and do a half, and then a half and a half. Put a little half and half in my coffee this morning. What's my first little tick mark gonna be? Pi over 4, good job. What's my next one gonna be? Yep. The third one's gonna be 3 pi over 4, and then we got our pi, right? Let's put some little pointy points in for our graph. What's the first point you're gonna put in? 0, 0? Yeah. We knew that when x was 0, our y was 0. So when our x is pi over 4, where's our sign gonna go? What was it? Up or down?
Down.
Why is it gonna go down?
It's a negative.
Because of the negative, right? So this one's gonna be at -3. Okay. And then at pi over 2, where do you think I'm gonna be? 0. Yep. And then at 3 pi over 4, I'm gonna be at up 3. And then I'm gonna come back down to 0. Right. And if you want to, you can keep going. It's just going to keep repeating in that same pattern, right? And come up to 3, and across, it's going to go down to 3, and come up to 0, it's going to go up to 3, it's going to turn. That's getting wider.